Okay, good morning. Good night. Dr. Nat here. So we're going to talk about this particular question from Web Design. My student from K13 asked this question. So if you are not from my class, you are more than welcome to take a look at this video and try to understand this question. Try it if you want, as long as you learn. Okay, so let's start. In the figure below, what is the direction of the current induced in the resistor at the instant the switch is closed? So the question is asking you the current induced in the resistor. So the key word here is induced. Okay, so induced. How do we get an induced current? We need a change. Okay, so the instant the switch is closed in the solenoid. So let's take a look at the diagram. I'm going to use my mouse. So the instant I close this switch, what happens? I will get current flowing in my solenoid, right? So my current flows from positive to negative, positive to negative. And is it increasing slowly or is it decreasing slowly? Because you closed the switch, the current is actually increasing slowly up to a point it reaches a stable value and then it remains that value. So how do we determine the magnetic field of this particular solenoid? So if you remember how to find the direction of magnetic field, we need to identify the direction of current flowing in the front part of the solenoid. Again, if you want to find out the magnetic field of a particular solenoid, you need to know the direction of current in the front part of the solenoid. Okay, so let's take a look at this solenoid. Our current flows from here to here. It flows upward, flows here to here, flows upward here, upward here, upward here, upward here, so on. So my point is, your current flows upwards in the front part of your solenoid. Now, using your right hand rule, curl your hands according to the direction of current. If your current is going upwards, it goes like that, right? It goes like that. If your current is going downwards, it goes like that. Okay, so here our current is going upwards. I curl my fingers going upwards like that, which means that my magnetic field is to the left. Again, I'm curling my hands according to the direction of current. The front part of that solenoid, the current is going upwards. So going upwards, my magnetic field is this way. And it increases slowly up to a point that the current becomes stable. Then the magnetic field also becomes stable and no longer increases. Okay. So that is your magnetic field from the solenoid. What is induced? It is increasing slowly this way. What will the coil try to do? It is increasing slowly this way. It will always try to oppose, right? So if it is trying to oppose, it will go this way. It does not like this change. I don't want this guy to increase. So it goes this way. Hey, go here, don't increase. So it's going this way, right? Okay, curl your hands like this. Your current is going like that in the resistor. Okay, again, your magnetic field is going this way. Your current is flowing like that in your coil, which means that the current is flowing towards you in the resistor. It's flowing towards you because your magnetic field is like this, your current is going like that, which means that when you look at the resistor, you are looking at it like this. The current is flowing towards you. Okay, what does it mean for the current to be out of the page? Out of the page. I have a page. My current flows towards me. It is going out of the page. If my current is flowing away from me, it is going into the page. Okay, again, I have a page. Okay, this is direction of my current. If my current is going out of the page, it means that the current is flowing, going out. right? If my current is going into the page, my current is flowing this way. Now, let's take a look back at this diagram. I said that the magnetic field, the induced magnetic field, is going to the right. Your hands goes like this, right? That is your direction of current. It is going towards you. What does that mean? The current is going out of the page. That is right. Okay, I hope this helps. Talk to you soon. Bye-bye.